Okay. It looks like many people are joining us. We've got a couple minutes. Now, we have a chat box, so if there's anything that you need to ask or anything, either unmute your microphone or just type something in the chat box. That is let's see, I think I've got open on the left side of the screen the enhanced assignment, and on the right side of the screen should be my video presenter where I can write notes. Alright, so today we're looking at limits and we're looking at some limit laws. So the limits are in section 2.2. Limit laws are in 2.3. Okay, so with the limits, algebraically, we can often just plug in the x value to find the limit. So in the one here I'm looking at, the limit as x approaches 1 of the function is equal to 5. They're asking if that limit exists, must f of 1 equal 5. So, is it possible for us to approach a 1 on the x-axis and approach a 5 on the y-axis from the left side and from the right side, but not actually fill in the circle? Maybe fill in a circle somewhere else. So in this picture that I've drawn, f at 1 would actually equal 2 because this point would be at point 1, 2. But the limit from the left side and from the right side is still approaching a y value of 5. So we'd answer their question, no, it doesn't require that f of x be defined. If f is defined at x equal 1, must it equal 5? Well, in the same picture, we did define f at 1, but it equals 2. So the answer would be no. As long as we are approaching the y value of 5 from left and right, then the limit is 5. Don't care what's happening at the actual point. That's not important. What's important is what's happening as I'm approaching from both sides. And so we don't have any conclusions about the value of the function when x is 1. That's not important to us. In continuous functions where there are no holes, then the function value would obviously equal the limit value because we'd be filling in the hole here. So this next question says, find the limit as x approaches 3 of the function negative x squared plus 2x minus 4. Well, this function is a quadratic. We know quadratics are parabolas. They don't have any holes in them. They don't have any asymptotes that we have to worry about. So we can literally just plug in 3 for x, since it's continuous. Since the function is continuous. So if I plug in a 3 for the x, I get a negative 3 squared plus 2 times 3 minus 4. Negative 9 plus 6 minus 4 is a negative 3 minus 4 is a negative 7. Okay. The next function is similar. It's also a polynomial function. We want the limit as x approaches 3 of 2x to the third minus 2x to the second plus 3x plus 1. Again, polynomial functions are going to be continuous functions. So again, we can just plug in the 3. 2 times 3 cubed minus 2 times 3 squared plus 3 times 3 plus 1. 2 times 27, that's 54. Negative 2 times 9 is negative 18. 3 times 3 is 9. 54 minus 18 is 36. 36 and 9 is 45. Plus 1 makes 46. Okay. Next function is a little bit different because it is not a polynomial function. This one's a rational function. And so we have to take into account any places that the function might be undefined. So this function is undefined if the bottom is 0. So it's undefined at x equals a negative 9. Since that's not where we're going, since our limit is approaching 8, I don't really care about that undefined spot. So I did need to check it out and make sure that's not what I was looking at. But once I know that's not what I'm looking at, not the value of x we're concerned with, then I can treat the rest of it like it was continuous. So I can just plug in the 8. So x plus 6 over x plus 9 becomes 8 plus 6 over 8 plus 9, 14 over 17. Now this becomes a little more complicated if I was looking at the area of x equal negative 9, but since I wasn't, we're okay there. All right, I'm going to swap pieces of paper now. Okay. So the next one's asking me for the limit as y approaches negative 8. And we have 19 minus y to the power of 5/3. Now this is a rational function, a radical function, because the 5/3 power is really saying the third root of 19 minus y raised to the 5th power. right? Since it's got a root, we call that a radical function. And radical functions, if they have even roots, must be positive under the square root. But since I have an odd root, it doesn't have to be positive. So there's really nothing that's going to cause a problem here, because with an odd root, I don't even have to have a positive under it. So I really can just plug in the minus 8. And we'll have the third root of 19 minus a negative 8 to the fifth power. 19 minus a negative 8 is 19 plus 8, that's 27. Third root of 27, fifth power. Take the root first or the power first. I'm going to take the root first because the third root of 27 is a 3. 3 to the fifth power is 243. If you didn't happen to know that off the top of your head, that's fine. You can use a calculator, but that's one that comes up a lot. So just from sheer memorization, I have that one. Okay. So the next question is asking me to find the limit as h approaches 0 of the function square root 10h plus 1 minus a 1 that's not under the square root all over h. Now if I plug in a 0, I'm going to get 0 over 0. Right, because 10 times 0 is 0, 0 plus 1 makes 1, square root of 1 is 1, 1 minus 1 is none, and on the bottom, if I plug in a 0, I get a 0. Now 0 divided by 0 is what's referred to as a indeterminate form. That is, we can't determine whether the top number is bigger or the bottom number is bigger. Determinate, and spell right, form. When we have an indeterminate form, we have to do something to try to simplify the equation. Because we can't get an answer. 0 over 0 doesn't tell me whether the top's bigger and it goes to infinity or whether the bottom's bigger and it goes to 0. So I don't know that. So what we have to do is we have to simplify and reduce before we plug in and that's the case anytime we have an indeterminate form. So in this case, the square root of 10h plus 1 minus 1 all over h, I'm going to multiply this by the conjugate of the numerator so that maybe I can get rid of that square root part. Conjugates help us get rid of the root. So the conjugate of the numerator would be the square root of 10h plus 1 minus 1. Of course, if you do it to the top, you've got to do it to the bottom the same way. So when I FOIL the top, I'll get 10h minus, or 10h plus 1 times 10h plus 1. Oh, you know what? I wrote my conjugate wrong. There was a minus in the original problem. There needs to be a plus in the conjugate. Okay. So when I FOIL, square root times square root times plus 1, minus 1 times square root, and minus 1 times plus 1. So this is going to give me a plus 1 square root 10h plus 1, a minus 1 square root 10h plus 1, and a minus 1 squared. Okay. The denominator, I'm not even going to bother because I think some things are going to cancel in a minute. So I'm just going to write it in its factored form. All right, so in the numerator, the plus 1 square root and the minus 1 square root add to be 0. So essentially, I don't want to say they cancel out, but they do add to be 0 and they're eliminated from the problem. So then the numerator becomes 10h plus 1 minus 1, and the denominator is h times the square root of 10h plus 1 plus 1. And that simplifies further because the plus 1 and minus 1 also add to be 0. We get a 10h numerator and an h times the square root 10h plus 1 denominator. Alright, so the next thing is the h in the numerator and the h in the denominator will cancel. H over h makes a 1. So I'm left with 10 times, by the way, I'm still doing the limit of all of this as h goes to 0, 10 times the square root of 10h plus 1 plus 1. So now if I plug in the 0, plug in h equals 0, we're going to get 10 over 10 times 0 is 0, plus 1 is 1, square root of 1 is 1. So we get 10 over 1 plus 1, which reduces to 5. So a little bit of work there, but understand where the work came from, multiplying conjugates to get rid of the square roots. And the only reason we had to do any of the work and we couldn't just plug in 0 to start with is that when we did, we got 0 over 0, which was our indeterminate form. So the indeterminate form is the reason we had to do all this work. We'll probably see some more indeterminate forms in the next few problems. Okay. So the next one's asking me for the limit as x approaches 13 of x minus 13 over x squared minus 69, or minus 169. All right, so if I plug in the 13, I get 13 minus 13 over 13 squared minus 169, which will again give me a 0 over 0 indeterminate form. So, what do we say we had to do? We had to simplify and reduce, right? Anytime we have the indeterminate form. Okay, so in this case, I don't have any square roots or anything. So conjugates don't make any sense. So what can we do with x minus 13? Not much. But x squared minus 169 is a difference in perfect squares. So I can factor that into x plus 13, x minus 13. Then the x minus 13s will cancel. And that will give me 1 over x plus 13. So I want the limit as x approaches 13 of 1 over x plus 13 should become 1 over 13 plus 13, or 1 over 26. All right, we got the limit as x approaches -7 of x squared plus 3x minus 28 all over x plus 7. And if we plug in the -7, we should get -7 squared, which is 49, plus 3 times -7, which is a -21, minus 28, which will give me a 0 on top, and -7 plus 7 will give me a 0 on bottom. So again, I got the indeterminate form. And when we have the indeterminate form, we are going to simplify and reduce. And then we'll try it again. So, the numerator will factor into x plus 7 times x minus 4. The denominator is x plus 7. Obviously the x plus 7's cancel. And we get the limit as x approaches a -7 of the x minus 4, which becomes -7 minus 4, or -11. Not ready for the answer yet. They want this one in pieces, so we'll fill in the x minus 4, and then we'll fill in the answer of -11. Okay. This next one is similar. T squared plus t minus 240 all over t squared minus 225. And we want the limit of that when t approaches 15. And again, that's going to give me a 0 over 0. So to reduce this would be t, what multiplies to be 240 and adds to be 1, subtracts to be 1. See, 24 times 10 won't do it. 20 times 12 won't do it. 18. What is 240 divided by 18? Anybody know that one off the top of your head? Nope. 240 divided by 15. 15 and 16. Okay, so that would be t plus 16, t minus 15. The denominator is perfect squares, so that's t plus 15, t minus 15. T minus 15's cancel. So we get the limit as t approaches 15 of t plus 16 over t plus 15. 15 plus 16 is 31. 15 plus 15 is 30. So we're going to get 31 over 30 for an answer. And we reduce that. Okay. We'll just keep throwing fun things at us. See, this next one, we want the limit v approaches 9, 1 over v minus 1 over 9, all divided by v minus 9. So if I plug a 9 in there, I get 1/9 minus 1/9, all over 9 minus 9. So again, it's an indeterminate form. So how do I simplify this one? Well, to simplify the numerator, I need common denominators. So 1 over v and 1 over 9, common denominator might be 9v in the numerator. So that means I had to multiply this v by a 9 to make it 9v. So I'm going to multiply this 1 by a 9. I'm going to get 9 over 9v. I needed to multiply this 9 by a v to make that 9v. So I multiply the numerator by a v, make it 1v. So this now becomes common denominators. I can group them together. Okay, I've got a fraction divided by a fraction, so I can write that the top times 1 over the bottom. Right? Keep it, change it, flip it, I believe was the expression. Now, my 9 minus v and my v minus 9 are very close to being the same thing. This is a positive 9, that's a negative 9. That's a negative v, this one's a positive v. So if I pull a negative sign out and swap the order, I can write this as the negative of v minus 9 over 9v times 1 over v minus 9. Then I can cancel my v minus 9s and I get negative 1 over 9v. Now I want the limit as v approaches 9 of negative 1 over 9v, my simplified form, which is negative 1 over 9 times 9, or negative 1 over 81. Again, what we're trying to find is the y value that the function is approaching when it's approaching the x value that's given to us. The function may not actually exist at that y value. In fact, it doesn't, which is why we've got the 0 over 0. But the function is still approaching a particular y value as it gets nearer and nearer to the x value that we're given. Okay? Next one, we want the limit. X approaches 81 of the square root of x minus 9 over x minus 81. All right, obviously if I plug in the 81, I get square root of 81 minus 9 is 0. 81 minus 81 is 0, so that's my indeterminate form again. How can I simplify this? I could multiply by the conjugate of the numerator, which is square root of x plus 9, or I could factor the denominator and pretend it's the difference of perfect squares, where my x, if I treat it as a perfect square, would factor into root x times root x. So this x, if I were to pretend it was a perfect square, would factor. And of course the 81 would factor into 9 times 9. One of them gets a plus, one gets a minus, and that allows me to cancel. So I get the limit as x approaches 81 of 1 over the square root of x plus 9. Plug in the 81, and I get 1 over 9 plus 9 is 1 over 18. Okay, this next one probably multiply by the conjugate of the denominator. We seem to be doing a lot of the same things. Here's at least a trig one. Let's do the limit x approaches 0 of the secant of x. Well, what's the secant of 0? Anybody know? What's the cosine of 0? The secant's 1 over the cosine, right? Cosine of 0 is a 1. 1 over 1 would just give us a 1. Think about your unit circle. 0 degrees is at 3 o'clock. That's on the positive x-axis. The cosine on the positive x-axis is a 1. Here's another one that uses trig functions. The limit as x goes to 0 of 1 plus 3x plus the sine x four times the cosine x. Alright, so if x is 0, 1 plus 3 times 0 plus the sine of 0, 4 times the cosine of 0. See, these aren't even undetermined, are they? Or indeterminate forms. This can be 1 plus 0 plus 0 because the sine of 0 is 0. Cosine of 0 is 1. It's going to give me 1/4. This is interesting. They're wanting some step in between. Not sure what they want. Let's put each term over the denominator. And then I guess we could rewrite sine over cosine as tangent. So we could write that 1/4 the tangent of x. It seems like extra work that's not necessary, but we'll do 1 over 4 cosine x. Then I've got 3x in the numerator over 4 cosine x. And then I've got tan x over 4 is a simplified way to write 1/4 tan x. See if that's what they want. Okay. I could write the 1 over cosine as secant, so I could do secant x over 4. I could do 3x, 3/4 secant x over 4. 3x secant x over 4 plus tan x over 4. Let's see if they want that. I don't know what they want. They want that simplified. Oh. Well, all right. You're saying it can't be simplified. I disagree with that. I think it can be. We just found 2 ways to do it. And maybe it's not any simpler in either of those 2 ways, but all right, we'll go with that. All right, this next question is asking us to consider a point xy lying on the graph of the line 5x plus 8y equals 7. So this is a line. Let L be the distance from xy to the origin. So x minus 0 squared plus y minus 0 squared square root, that's the distance formula. That distance would be L. All right, the origin is the point 0, 0, the other point's x, y. Right, L is a function of x, which means we don't want any y's in there. So how about x squared plus y squared equals L squared? If we change this up a little bit, solve this for y, oops, x minus 7, and that equals minus 5/8 x minus 7/8. And since this value is y, we can plug that right here.
I don't think we can see your screen.
Okay. That's not good. Can't see anything on my screen?
I know at least I can't.
Okay.
No, I can't see anything either.
All right, that could explain a little spinning color wheel that I'm seeing on my screen. That may mean WebEx is out.
We can hear you, except you're not labeled as the host anymore. We just see the classmates on here.
Huh. It kicked me off my own meeting. That's terrible. Okay. Well, I guess we can talk about it verbally on this question anyway. And then I'll probably just go ahead and jump to limit laws because I can talk about all that verbally. Can you see any part of my screen, or I'm just blank?
No, nothing.
Okay. Well, to finish this problem, I guess we're gonna take the equation of the line they gave me and solve for y. So I'm gonna get I'll move the 5x over and divide everything by 8, and I'll get y equals minus 5/8 x minus 7/8. And so in the equation of x squared plus y squared equals L squared, I'm going to replace that y with its value, and I'll get x squared plus the negative 5/8 x minus 7/8 all squared equals L squared. I'm not going to bother foiling that out, but that's the path. And actually, we could probably type it in without foiling it out. All right, so I'm going to, goodness, I'm just frozen up as far as WebEx goes. You can still hear me though, okay? Let me see what I can do for WebEx. I'm going to try to leave the meeting and come back if I can. I'm going to quit WebEx. Incident report. So I'm going to do that. Okay, is it letting me back in?
Yeah, we can see you now.
Yay.
Or I can.
Alright, let me see if I can get my screen back so you can see it. See the screen again?
Yep.
Okay, good deal. I don't have any idea why they wanted to do that, but so be it. Alright, well let's to save you from complete and utter boredom, let's jump to the limit laws. And actually it might even be easier if I jump in here to your book and we look at them as they're printed. They're really pretty simple. And they're a bit common sense too. For example, if you have the limit of two functions and you add the functions, then you would add the limits also. Oops, that's not what I want. Apparently limit laws is still in 2.2. I thought it was in 2.3, but back, go back again. We'll get there eventually. It's not going to be as much for me to write, so I can probably show more of the other screen. Okay. My menu bar has disappeared. I don't know why that's the case. Oh, there it is. I scrolled down. There we go. Alright. The e-text, chapter 2, section 2.2. I guess this is better than not meeting at all, but it's not ideal. You do too many things on one little screen, I think. Well, it's taking a while to load this, isn't it? Maybe we'll just Google limit laws. So, okay, if you have the limit of f and the limit of g, those are two different functions, right? And you add the limits, if you add the functions, you can add the limits. If you multiply the functions, you can multiply the limits. If you divide the functions, you can divide the limits, so long as neither of them are 0. If you multiply the function by a constant, you can multiply the limit by a constant. Yeah, there we go. Finally. Function, I'm going to get over to limits, to the limit laws. I'm just trying to turn the page. Alright. Let's turn the page again. So I just want to emphasize the whole idea with limits again is that they are y values. They are the y values that the function is getting near to as you approach a particular x value. The function does not ever have to equal that y value. So if there's an open hole in the function, or if there's an asymptote, it is possible for the function to have a limit but not actually ever exist at that point. Alright, so here are the limit laws. The sum rule. If I have two functions and they each have a limit, and I add those two functions together here, I can add their limits together. If I want the limit of the two functions subtracted, I can subtract their limits. If I want the limit of a constant times the function, I can multiply the constant by the limit of the function. If I want the limit of the two functions multiplied, I can multiply their limits together. If I want the limit of the two functions divided, I can divide their limits so long as the bottom limit's not 0. If I want the limit of the function raised to a power, I can raise the limit of that function to the power. If I want the limit of that function taken to a root, I can take the root of the limit of the function. So these are the limit laws. They're pretty intuitive. I mean, anything you can do with a function, you can do with its limit, basically. The one exception, the one area we had a problem was we got to make sure that we don't try to divide by 0. But as long as we're not doing that, we're good. Okay? Alright, now I'm going to try to close the textbook. Now, since you all have access to this, you can pretty much print this, write it in your notes, whatever, hang on to it, take a picture of it with your phone, but it's really very intuitive. Again, if you're adding, add the limits. If you're subtracting, subtract the limits. If you're multiplying by a number, multiply the number by the limit. If you're multiplying two functions, multiply their two limits. If you're dividing, divide their limits, so long as the bottom one's not 0. If you're raising to a power, raise the limit to the power. If you're taking to a root, raise the limit, or take the root of that limit. It's just not a big deal, I hope. I hope it's very intuitive. Alright, I'm going to close this page of the e-text, and we're going to go back to the 2.2 assignments and see if we can get some that involve the limit. Now, one thing I also did last night is I found some videos from the publisher, and I put those on your homework list. All right, the intent there is not that you have to watch the videos, but that they're in with the homeworks if you want to watch the videos. If you get lost and feel like you can benefit by watching the videos, please do that. Okay. But again, it's not a have to. I'll remove them from the gradebook entirely, but I wanted them to be available. So if you see here in the assignment list, Module 1, Section 2.1, I put the video on rates of change, tangent lines to curves before the assignment. And so today the video on limit of a function and the limit laws come before the assignment. Just extra, not that you have to do them. I put the video on the precise definition of a limit before the assignment. So anyway, when I found those, I thought that might be extremely helpful for some of y'all to have access to.
Did you want us to complete the assignment before this class period? Because I saw that it was due, I think, on Wednesday, and I hadn't completed it yet.
I changed the due date. It's due this coming Wednesday. No, we only had talked about half of it, so no, I didn't necessarily want you to have completed it. This first little bit, since we had to squeeze in an orientation, we kind of got a little bit off, and so I'm very flexible at this point. But we had not finished that whole discussion in class.
I understand. Thank you.
Sure. Here we go. It looks like number 23 may be the first one with the limit laws. So they're telling me the limit of f is 8 and the limit of g is -6. So f times g would be 8 times -6 is -48. Now we have 3 times f times g, so that's going to be 3 times 8 times -6, be negative, I don't know, 154? 144, maybe, if I'm doing my multiplication right in my head. This one's asking me for f plus 7 times g, so that's going to be 8 plus 7 times -6, or 8 minus 42 would be a minus 34. Then we're asked for f divided by f minus g. That'll be 8 divided by 8 minus -6, or 8 over 14, or 4 over 7 when we reduce that fraction. So here we expand that to 3 functions. The limit of p plus r plus s is going to be 7 plus 0 plus -4, which will be 3. It's a nice relaxing assignment, isn't it? The limit of p times r times s would be 7 times 0 times -4. 7 times 0 is 0, and 0 times -4 is still 0. So we'll get a 0 answer on that one. The limit of -3 times p plus 5 times r divided by s is -3 times 7 plus 5 times 0. That'll be -21 plus 0 is still -21. Divided by -4 becomes a positive 21 over 4. This making sense? Okay, I need to go back to my presenter screen just a second. So that you can see this as I work it out. That might be a little more helpful. Okay. In this one we've got the limit as h goes to 0 of f of x plus h minus f of x over h when f of x is given to be -3x minus 2 and h is, or x is 5. Okay, so first we have to evaluate the limit, then we plug in the x. After we evaluate the limit. So f of x plus h will be -3 times x plus h minus 2. Right? We plug x plus h in where x used to be. So that's going to give me -3x, -3h, -2, +3x, and +2, because don't forget that negative sign will distribute all over h. The -3x and the +3x, the -2 and the +2, all add to be 0. Then the h's cancel. I get -3. Then I plug in x equals 5. And there's nowhere to plug it in, so I still get a -3. That was fun, wasn't it? Okay, here's another one with, this is called the difference quotient, by the way. You probably heard that. You may have even calculated some difference quotients in Algebra 2. Quotient means division, difference means subtraction, so get subtraction on the top and then division. So we've got the limit as h goes to 0 of f of x plus h minus f of x all over h. And remember the other day I talked about this as being the slope formula. y2 minus y1 over x2 minus x1, where the distance between x2 and x1 is h. Okay, so now they are telling me that f of x is the square root of x. So f of x plus h would be the square root of x plus h, right? And then we plug in x equals 7 when we're done simplifying this. So if I plug in a 0, I get 0 over 0, so that's indeterminate. So I'm going to multiply it by the conjugate of the numerator to get rid of all those square roots. So that'll be the square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. And we'll FOIL that numerator. So I'm going to get x plus h when I do first times first. Outside and inside go away. And I'll get minus x when I do the last. And then on the bottom, I'm not going to worry about it because I'm going to try to cancel some things. So my numerator ends up being just h. My denominator then is h times the conjugate. The h's cancel, and so I get 1 over the conjugate. And I've got the limit of that as h goes to 0, becomes 1 over square root x plus square root x, or 1 over 2 root x. So then I plug in the 7, and I get 1 over 2 root 7. Okay. If 6 minus 6x squared is less than g of x is less than 6 cosine x, find the limit as x goes to 0 of g of x. Well, the limit of g of x is going to be between the limit of the smaller and the limit of the larger. It's called the sandwich theorem. Right? If you're the piece of bologna, you have to stay between the two pieces of bread. So if you're above this piece of bread and below this piece of bread, you're always going to be above and below the pieces of bread. So what happens when those pieces of bread have an x value of 0? So what happens when 6 minus 6x squared goes to 0? Oops. Oh, that should be 6, not a 0. And then g of x is in the middle, because g of x is our piece of bologna. And our top bun is 6 cosine x, which becomes 6 cosine 0, or 6. So now my bologna is between a 6 and a 6. So I guess my bologna better be a 6 also, or my function. It's called the sandwich theorem. Right? If you're in the middle of the sandwich and the top and bottom pieces of the sandwich go toward a certain value, you have to stay between them. There's only one place you can be. All right. This looks like another sandwich theorem. As x goes to 0, this becomes 1 minus 0 over 6, or just 1, and that stays a 1. So this has to also become a 1, again, due to the sandwich theorem. So that limit is a 1. That was a complicated looking question, but again, it's based on that sandwich theorem. So if 1 is a horizontal line, and 1 minus x squared over 6 is quadratic, so that's going to be a parabola. It looks to me like choice, oh, in this middle function, I don't know what it is, but it has to stay between the 1 and the parabola. Looks like B is the only one that has a function in between the horizontal line and the parabola. As x approaches 0, all three graphs become 1, so that seems like C is the better answer. Well, apparently not. Maybe I didn't read it all the way. Okay, B was the better answer. Alright, so this is another sandwich theorem one. No, that's the same question. That's the exact same question. Alright, well, ought to be easy to get it right this time. Let's see if I can find the right picture. D is now the correct picture. And all three graphs get close to each other is answer choice A. I didn't read the second part of the answer choice. Okay. And in this problem, it looks like we are just plugging in numbers for x and seeing what the y's are. So this is a calculator problem. I'm not going to spend time worrying about that because you can see on your calculator as you plug those values into the function. And 30 is also a calculator problem. Okay. So we are kind of out of material for today. Do y'all have any questions before we just wrap this one up?
I left a question earlier in the chat on using the finding the indeterminate form. Do we need to do that with substitution if we know or can see that it's going to be an indeterminate?
If it's going to be indeterminate, then you've got to do something to it to still be able to plug it in, because you can't answer 0 over 0 when they're indeterminate. You've got to either multiply by conjugates or factor and cancel, but in some way, shape, or form, you've got to simplify that problem before you plug in the 0 so that you get something other than 0 over 0. Right, if you know it's going to be 0 over 0 because you can just see the algebra in your head, you don't have to show that it's going to be 0 over 0. You can go ahead and do the transformation of the function so that it doesn't end up being 0 over 0.
Okay, I understand.
Okay. All right, anything else? All right. If y'all don't have any other questions, we will end our meeting. And I will hopefully see you Wednesday, but since there's another hurricane coming, who really knows? Um, if we get hit again, maybe we'll meet on WebEx on Wednesday too. All right, y'all have a good one. Bye.